Unit 11, Section 11.4. Today we're going to look at a new type of angle called an inscribed angle. So previously we looked at central angles, and that's where we said, okay, the angle equals the arc. And so if you notice on the next piece, now we're going to look at inscribed angles. So this is going to be a different relationship looking at, again, where those angles are and how do we find their measures. And so we'll spend 2 days looking at inscribed angles, so 11.4 and 11.5 here. So starting right off with what that angle is, an inscribed angle is an angle whose vertex is on the circle. And its two sides then are going to be created by chords, or it could be diameter and a chord. And so an inscribed angle like this is an inscribed angle. Notice that this vertex is on the circle. The intercepted arc is the arc that lies between the chords and the inscribed angle. And so if I extend these out, here's chord AB, here's chord BC, this piece here, so arc AC is the intercepted arc. Squish that in there. And so the way that we find the measure here, this isn't going to be the same measure as our central angle, because if I drew in the central angle here, let me grab my drawing line tool, the central angle would be here at the vertex, or I'm sorry, at the center of the circle. The vertex is the center for a central angle. So if I looked at this, well, now I have this angle, okay, looking at this one, and then I have this angle. And so the difference here, these are not the same measurement. Do you see that this one is bigger and this one is smaller? So our inscribed angle is always smaller than its central angle that goes with it, capturing that same arc. And the way that we relate those is that the measure of the inscribed angle is actually equal to half the measure of its intercepted arc. So if I was looking at this, angle ABC, that's my angle that's on the circle, is going to equal 1/2 of the measure of arc AC. And so when we're looking at this, I have frequently had students that were like, oh my gosh, we have fractions involved here. Let's go ahead and make this, instead of half of the arc, I could say, and this is what I typically use more often, 2 of the angle here equals the arc. Because if I multiply this side by 2, that gets rid of my fraction, which again, that's not an F word, but sometimes people think it is. And then if we multiply 2 on this side, this is where I get the 2 times the angle on this side. A special case would be if an inscribed angle intercepts a diameter. Okay, as soon as I have a diameter, I know that this is 180 degrees. They don't have to tell me the measure here. As soon as I know it's intercepting 180 degrees, then we can make this inscribed angle a right angle. So that will create 90 degrees here as we pull that back. Here's 180 degrees, here's 180 degrees. Half of that will get me the 90. 2 of this gets me the 180. So the measure of angle BAC, turning here at A, is 90 degrees. And that's a special case anytime we intercept a diameter. And the last kind of special case, looking at these two, is if 2 inscribed angles intercept the same arc, then the angles are congruent. And so that goes along with if I have 2 angles here. So maybe I look at ABD. So I'm going to trace that out. A to B to D. Okay. Notice that this angle is intercepting this arc here, A to D. So I have this arc being intercepted. If I look at another angle, angle ACD. So if I trace that out, I need to practice my tracing skills here. If I trace these out, this is going to intercept that same arc here. What that tells me is that as I pull this back to this angle or to our other angle that we started with, these have to be the exact same because they're intersecting the same arc. And the way that we find the measure is 2 of the angle equals the arc. So 2 of this would equal this, 2 of this would equal this. If they're the same arc, these are the same angle. That will happen every time. So the measure of ABD, we don't know what this measurement is, but we know it has to be the same as angle ACD. And again, I'm just tracing out my angle. This is where I turned. I could have named this DCA as well. So let's get into some of these examples, practicing the idea that 2 of the angle equals the arc. So that's kind of our main rule that we're using with any angle that's on the circle. We're going to say 2 times the angle equals the arc. And so as we're looking at this, find each angle and arc measures. Okay, this is looking for an angle. So we're going to say 2 of the angle equals the arc. And so I'm going to plug in what I know from the picture. Okay, so I'm looking for WXY. Okay, so I don't know what this angle measurements. So I'm going to say 2 times X, because I don't know what the angle is, equals the arc. Okay, so if I trace this out, here's my angle. Notice that it's capturing the arc that's 62 degrees. I can undo this multiplication to find what that angle measures. Divide both sides by 2, and I get X equals 31. That's going to give me my angle measurement here, telling me that the measure of this angle is 31 degrees. Again, on number 2, here's my vertex. It is on the circle, telling me I should be doing 2 times our angle equals the arc. In this case, I'm looking for the measure of arc DGF. Okay, so now this is the arc that I don't know. So that's where my X is going to be. I'm looking for this measure of an arc. I do have the angle that goes with it. So again, if I trace this angle out, I can say 2 times the angle. In this case, I know the angle is 113. And that should give me this big major arc on the outside, which is my X value. Multiply 2 times 113. Okay, maybe I need my calculator for that. We can pull that up. 2 times 113. Oh, we should get 226. I should double those numbers. And that's going to be our measurement here. That's telling us this major arc, which visually makes sense. It's more than 180 degrees. We'll measure 226 degrees. On number 3, okay, we're looking for the angle PQR. P, turn at QR. So this is where our X is. 2 times the angle equals the arc. I do this because I see Q is on the circle. All right, so we're looking for this angle, so 2 of the angle, so that's going to be X equals, okay, well, I need to trace this out. So I have here to here. So it's capturing from P all the way around to R. They're not giving me those measurements, and I can't put a different variable here because I can't solve it if I have 2 unknowns. So what the new piece is here is this is one of our special cases. Notice that they gave us a diameter. As soon as we have a diameter, we know that arc has to be 180 degrees. So that was a special case that they gave us here. Our angle X is capturing a diameter, P to R. And because of that, the arc that it's capturing has to be 180 degrees. Based on our rule here, we know that angle should be 90, but it should follow the same rule. 2 times X equals 180. Divide both sides by 2, we still get that 90. That's going to happen every time we have a diameter. So if we have a diameter, the arc is 180, the angle is 90 every time. On number 4, okay, I have an angle, so I have this angle here. Again, it's on the circle, giving me that rule that says 2 of the angle equals the arc. Okay, so 2 times, okay, I know the angle measurement of 47 equals the arc over here that it's capturing, A to C. So that's going to be my X value. All right, 2 times 47, let's find that in our calculator. We get 94. Okay, so we have 94 degrees here for x, and that is our A to C measurement. But then it's asking us for another measurement. It's saying, okay, if A to C is 94, what about B to C over here? And notice that I'm using some colors to kind of associate those pieces together and see the different parts. I think coloring, having colored pencils or highlighters kind of help in this unit if you need those. So what about this piece? What does this measure? We have another variable here. Notice that again, just like we had over here, we have a diameter drawn in. So because we have a diameter, we know the arc on this side is 180. So the whole circle is 360. Or we could do this entire side has to be 180. Either way, we can find this missing measurement. We know that this plus this equals 360, or these two equal 180. So I can take 360, the whole thing, and subtract the 180 from the diameter, subtract the 94 from our angle there, and we get 86. Or I could have said, okay, I have half a circle on this side, subtract 94, get the same 86. Either way, our measurement here, using those arc measurements that we did on our last unit, helps us find the measurement there. On number 5, okay, turning the page over here, we are looking at the measure of JKL. So this is another angle. Okay, I'm looking at the vertex that is on my circle, meaning I'm going to do 2 times the angle equals the arc. All right, so 2 times our angle. Okay, so I'm going to put my x there because that's overall what I want to find. So 2 times x equals, okay, so trace it out. Man, I'm not very good at tracing there. It's capturing JM all the way around to L. That's not a measurement I have. And again, I already know this is what I'm looking for. I can't introduce a new variable. So how do we find this arc measurement? Well, we go back to the idea that we have 2 other measurements. The whole thing, all 3 of these must add up to 360. So I'm going to take our 360 total of all the angles and subtract the 65. That's not part of the big arc over here. And subtract the 53. That's also not part of the big arc. Leaving me with 242 degrees for the arc out here. So my arc is 242. Now I can solve this for that missing angle, JKL. Divide both sides by 2, 1, 2, 1, and that'll be the measurement of our angle, 121 degrees. On number 6, okay, we're finding 2 things. So RST, here's RST, so I'm going to put X here. And RUT, I'm going to put a Y there. I'm looking for 2 things there. Okay, so let's focus on RST. This is an angle. S is now on the circle. So we're going to do 2 times the angle equals the arc. Again, writing this over helps us memorize these rules. So 2 times the angle, that's going to be 2 times x, equals, okay, the arc that goes with it is this arc over here. And again, we don't have that arc, but we have 64, we have 139, we have 75. The only thing we're missing is this one. So going back to my calculator, I can find that by subtracting all the pieces I have, 64, 139, and 75, getting 82 degrees here. So the arc R to T is going to be 82 degrees. Divide both sides. 8 divided by 2, 1 divided by 2. This is going to give us 41 degrees. If we look at RUT, okay, so this is this angle. This is another angle that's on the circle. 2 of the angle equals the arc. And now we have 2 of angle Y over here, but look that it's capturing the same arc. That's the same 82 degrees that we found when we did this one. That's why this is going to be the exact same. They captured the same arc. And that's our other special case that we had here. Intercepting a diameter, special case here, we have to know the 180. Two angles intercepting the same arc, those measures are going to be congruent. Oops, sorry, jumped again. All right, on number 7, we're switching gears a little bit more to the algebraic. Now we have a variable already here, and it just says solve for x. So on here, find the measure of each, or value of each measure. So if I put my vertex here, that's on the circle, telling me this is 2 of the angle equals the arc. And so what I want to do is set this up. 2, notice they're giving me that angle measurement, 8x minus 9. Equals, okay, here's my angle, and we know the arc that it's capturing. There's the arc, 158. And so now I'm going to use my algebra skills to get x by itself. So I'm going to distribute 16x minus 18 equals 158. I'm going to add 18 over to the other side, undoing that subtraction. So I get 158 plus 18 is 176. And undo that multiplication to get x by itself. 176 divided by 16, and we get x equals 11. I could plug this back in to check my work. 8 times 11 is 88, minus 9 is 79. All right, so 2 of that angle should equal arc. So let's see if we say 2 times 79 should equal my arc. There's the 158 we were expecting. So I know that I've checked this and have the correct answer. I'm going to do the same thing on this one. This is an angle M that is on the circle, so we'll do 2 times the angle equals the arc. And so here we'll do 2 times, this case our angle is 67, so just like I put this in parentheses here, I'm going to put this here in parentheses. Equals, okay, trace out our arc. Yep, so this captures the arc L to N here, giving me 4x plus 58. And again, now I'm going to use my algebra skills to get x by itself. So I'm going to multiply 2 times 67 to get the left-hand side of 134. And then I have 2 numbers on this side, keeping x from being by itself. So I'm going to undo addition by subtracting. And I get 76. Bringing down our 4x. Undo this multiplication with division. Divide by 4. And we get 19. There's our solution. Again, just like we did before, we can check here. So plug in 19. 4 times 19 plus 58. 4 times 19 plus 58 is 134. And 2 of the angle should equal the arc. So 2 times 67 should equal the 134. Oh, we kind of already had that there. But we've checked our answer. We know this one is correct. All right, so on our next one. All right, again, we're solving for x on these last ones. We're going to have, here's our x variable, but the angle x is on the circle, telling me 2 of the angle equals the arc anytime I have an angle that's on the circle. 2 times our angle here. Okay, do you see they're telling us this angle here is 13x minus 1 equals, okay, so now we have the arc that goes with it. I don't know, I always squiggle my arcs and straight lines for my angles. There's no measurement over here. So how do we know what this side measures? I can't put another variable if I'm already trying to find x here. All right, hopefully we're looking for those 2 things we could have, a diameter or other arcs defined. Here's our diameter, telling us each side of our diameter, 180 over here, 180 over here. So we had to use, again, the diameter to get that 180. Knowing this is a diameter gets us that 180. Once I have that arc, now I'm using my algebra skills again to solve. 2 times 13 is 26. 2 times -1 is -2. And I'm bringing down the 180. I have two things to move before I have x by itself, so I'm going to undo that subtraction by adding it to the other side. I can do that in my head. And undo this multiplication with division. I got to get a calculator for that one. I don't know the factors of 26 there. Oh, it goes in nicely. X equals 7. Check our work. We can plug in 13 times 7 minus 1. And I get 90. Good. Okay, 2 of my angle. If this angle is 90, 2 times 90, there's my arc I wanted. There's that 180, knowing that this is correct. On number 10, here's our angle here. So we have 114. Okay, where are we solving? Here's our x. Okay, so I need to move my piece here. I was drawn to this one, but my x is over here, where we have an angle on here. So this is where my x is, so that's where I want to use the 2 times the angle equals the arc. Okay, so 2 times my angle, they told us, is measured as 7x plus 6. And if I trace out my angle here where x is, okay, here's my arc. Uh-oh. We don't know what this is, and so maybe we have a diameter, so we know it's 180. We didn't go through the center. Okay, so then we need to start figuring out what is this arc that we're going to plug in here. What else do we have? We have 78 here, but we still don't know what this measurement is. All right, so we have kind of two pieces going on here. We need these two arcs. This arc is what we need for our equation to find x, but we have to find this arc in order to find the missing piece here. We know that 78 plus this missing arc plus this one equals 360. And what we haven't used is this 114. So I was drawn to it because it is another on angle. So if I went 2 times 114, notice that if I trace this out, it's using all of this. So if I take 2 times 114, again, I think I can multiply by 2 in my head, 228. We should get the arc that goes with it. This is 228. I don't know what this measurement is because this is the 7x plus 6. Once I find this and I know the other 78 though, this is how we can manipulate that 360 degrees, subtracting the 228 we used the 114 for, subtracting the 78 that they gave us to find this arc is 54 degrees. So again, there's really two things that we're manipulating here. Diameter, boom, we have 180. Otherwise, we need to manipulate that 360 using every piece of information they gave us to now find this missing arc so that we can distribute and solve. So I'll distribute here. 2 times 7 is 14 plus 2 times 6 is 12 equals 54. I'm going to subtract 54. Or I'm sorry, subtract 12 from 54, giving me 42. And divide by 14. I get x equals 3. All right, so again, we could check our work plugging in 21 plus 6. 21 plus 6 is 27. And 2 times 27 gets me my 54. So I know that's correct. Check it on your calculator, do it quick in your head. But if we get a negative, it better plug in and become a positive angle. X can be negative, rarely, but when we plug it in, all of our measurements will be positive. All right, so here's our last two. All right, still looking for x on both of these, so I'm going to start out here looking at my on angle where x is. So 2 times our angle equals the arc. And I'm going to set up our equation. 2 times, they're telling us, pointing at this angle, is 7x minus 10 equals the arc that goes with it. Whoops, sorry, hit a button. So 7x, 2 times 7x minus 10 equals, okay, trace out our arc. And then here's our arc that connects it, and we don't know what it is. Again, diameters or manipulate the 360. I don't have a diameter, it's not going through D here. So I'm gonna manipulate the 360 by taking the total 360 and subtracting the 162 from this arc and the 92 from this arc. And once I subtract that, I know that that missing arc I didn't have has to be 106. I know the whole circle is 360. Now I can go ahead and use my solving skills to get x by itself. Excuse me. 2 times 7 gets me the 14. 2 times negative 10 gets me negative 20, and I'll bring down the 106. Undo subtracting, adding it over to the other side. Undo the multiplication by dividing, and we'll get x equals, again, got to get that in my head, 126 divided by 14, we get x equals 9. I can plug in to check my answer. So I can do 7 times 9 minus 10. I get 53. 2 of those angles should equal my 106. So I know that my arc and angle and x all are correct. All right, last one we have here is 2 of our angle. Okay, well, our arc is over here. I got excited again where I put the on. I'm seeing that. But now this is my arc over here that I'm missing. All right, so I'm going to use this angle and still set that up. 2 of my angle equals the arc, because if I need arc measurements, I'm seeing that I know this is 120 and this is where my x is. So if I find this arc, I should be able to use the 360 idea to help me solve here. So we're going to do 2 times the 67 is going to give me this arc out here. And maybe I don't want to use x. Maybe let's use y out here since I'm looking for x here. All right, so 2 times 67, I get 120, 150. Why am I not doing this on the calculator here? All right, we get 2 times 67. Oh boy, I was off, 134. All right, so this is where we find y. So we know that this arc out here is 134. And if we go all the way around the circle, we know that 134 plus 120 plus this arc that we're looking for should be 360. So I'm going to solve this a little bit down here. I'm going to say, okay, we know 134 plus 120 plus the arc that we have, 5x plus 21, should all add up to all the angles in there. That would complete the circle, 360. All right, this is an equation I can use to find x. So I'm going to combine my like terms. All right, so we have 134 on the same side. We have 120 on the same side, and we have 21 on the same side. So I'm going to combine all those on the same side, trusting those signs. Okay, so now I have 5x plus the 275 from combining my values there equals 360. Okay, and then I'm going to subtract and divide. So I'm going to subtract 360, subtract over the 275, trying to get x by itself. 5x equals 85. And 2 steps there. We have 1 step left. Let's divide both sides by 5 to undo that multiplication. And we get x equals 17. All right, so if I plug this in, now I'm checking not the angle, but the arc. So 5 times 17 plus 21. Okay, so this is 106 plus 134 from this arc plus 120. All 3 of those should add up back to 360. So I know that's correct as well. So today's main formula that we're using is 2 of the angle equals the arc. We have a couple special cases as far as a diameter will always give us an arc that's 180 degrees. And remember that we can always go back to the basic characteristic that all the angles of a circle are 360 degrees. So we have those two things that we always know are true that we can use to our advantage when we're missing pieces of a circle. Let me know if you have any questions, and I'm happy to help.